right, so which system of equations has the same solution as the system below? So let's check each of them, okay? 2x, 2y, and 16, well, that's the same thing, so that's a check, okay? Now, in my other classes, a student came up with a very good strategy. So what he did was, we can take this number here and this number here and divide it. So for example, 6 divided by 3, that's 2, okay? We can do negative 2 divided by negative 1. We see that's also 2. And then if we do 4 divided by 4, we see that's 1. Notice that they're not all the same, so it's different. So we know that 1 is not the answer, because it has to be all the same numbers. Okay, it has to be all the same numbers. The numbers are not the same, so we know it's not choice 1. Okay, let's go on to choice 2. Once again, we see the top choice is the same as over here, so that's good. Now let's do the same strategy. Okay, we're going to look at this number here and divide it with this number here. 6 divided by 3, well, that's 2. Negative 2 divided by negative 1, that's 2. And then 8 divided by 4. Now, what do you notice? They're all 2. Okay, so that means that we found our other one. So our solution is here. We can just stop right there because they're all the same. Okay, for choice 2. So we see that the y-intercept is 2. That's going to be our starting point. So I'm going to go to the y-axis, and I'm going to put my point on 2. Then I see that my slope, the slope is a number right next to the x. It's 2 over 1, so that means I'm going to go up 2, and I'm going to go down to the right 1. So from my point, from the starting point, I'm going to go up 2 to the right 1. Up 2 to the right 1. I can also go down 2 to the left 1. Down 2 to the left 1. Okay. And then once I have my line, I can just, a couple of points, I can just draw my line. I don't have a ruler. Okay? So we just graphed that one. Now let's look at this one over here. So Sammy, you may want to learn this method. Okay?
No, I don't like that method.
You don't like it?
I like my chart, and I always don't like it.
All right. Okay, starting point. Okay, what's my starting point here, Lynn? Lynn, what's our starting point? Right, the y-intercept, right? Where am I going to start? Negative 1. We always start in the y, not the x. We always start in our vertical line. Okay, now.
Would it give you a different answer if you start at x?
Yeah, you will. It would. You always start in the y-intercept. That's what they call it, the y-intercept, because it intercepts the y-axis. Now, when you encounter a slope that's not explicitly there, there's an invisible 1. 1 over 1. Okay? So, we're starting at -1. So from the point that we plotted, okay, we're going to go up 1 to the right 1. Up 1 to the right 1. So now you're going to get a line that is more, more accurate. Okay, if you try to graph it from the calculator, it's going to be off if you're just looking at, from the eye.
I don't do it. I just plot my points.
Well, that's a perfect method too. Okay, so when you draw your line, okay, this is your intersecting point. And then your intersecting point is -3, -4. Right, you have to write solution. Okay, so we have to find the x-intercept and the y-intercept. So we know when it's the x-intercept, we know that y equals 0. And the y-intercept, we know that x equals 0. Okay. So when y is 0, we forget about the y. And so it's going to be 2x equals 8. So it's going to be 2x equals 8. We solve for x, so we divide by 2. And we get x equals 4. So that is the x-intercept. That means it's going to be on the x-axis. It's going to intersect the x-axis. So we draw a point at 4, 0. In the y-intercept, x is 0. So we forget about x. So y is just going to be 8. We don't have to do no calculations there. So y is just going to be 8. That's the y-intercept of the other one. So it's going to be at 8. And then we can do the other ones. Okay, so in this case, we're not plotting as many points. We graph both lines. Okay, and we see that the intersecting point is right here. So the solution, so you have to say the solution is 4, 0. Okay, so we have 2 large posters, 3 small posters. So we're going to say 2L plus 3 small is 1680. And the other one is going to be 1 large plus 4 small was paid $14.50. So that's how we write the linear equation right there. Very straightforward. We're going to use we're going to use the substitution method, our famous French fries for onion rings.
I hate that.
You hate that? Okay, so this is going to be, it's kind of putting everything that we've learned together, all together, okay? So a family bought a total of 16 adult and child tickets. So it's always going to compare 2 things. You have to see what's being compared. So we're seeing that we're comparing adult tickets and child tickets. So we can say A represents the number of adult tickets and C represents number of child tickets. So right here, we have our first equation. A total of 16 adult and child tickets. They're not specifying what, which is what. So we can say that A plus C equals 16. That's my first equation. The number of adult tickets for the number of child tickets is 16. And then they tell us the adult tickets are $10.50 each. The child tickets are $7.50 each. And they paid a total of $141. So that gives me my second equation. So I'm going to say $10.50 times the adult tickets plus $7.50 times the child tickets equals 141. Okay. Once I write my equation, I'm going to use the substitution method, right? Where I'm going to swap the French fries for onion rings. However, I see that none of the variables are by themselves. So that's the first step. I have to get one of the variables by themselves. So what I'm going to do is I'm going to subtract either A or C. It doesn't matter. Right? Because I want to bring one. Let's say I'm going to bring C to the other side. I'm going to subtract C. So A is going to equal 16 minus C. So right here, once you have a variable by themselves, you can see, let's say the French fries, you can see the onion rings. I'm trading A for 16 minus C. That's my trade. That's what I'm doing my substitution. I'm trading A for 16 minus C. So I go to my other equation. Okay. My other equation is 1058 plus 750C is 141. But what am I going to trade A for? I'm going to trade A for 16 minus C because I don't want A. I don't want French fries. I want onion rings. So let's do the substitution. So this is going to go in here. So now I'm going to write 1050 times 16 minus C. All right, that's my substitution. Plus 750 C is equal to 141. So now we do distributive property. What is 1050 times 16? Put that in the calculator. 1050 times 16. 1050 times 16 is 168. 1050. 1050 times negative C is just going to be negative 1050 C, right? So 1050 times negative C plus 750 C equals 141.
What the heck?
Okay, so let's just look at this. It looks complicated, but it not necessarily.
It is complicated, boy.
You just call him boy.
Not for you, but
Now, because we have, notice this, we have a negative 1050C and 750C. Those are like terms. So I can combine, I can put this in my calculator. Negative 10.5 plus 7.5. So I'm going to go to
I drink water.
give me a second. How do you get out of here? Anyway.
Like, are you meant to be serious?
So we're going to do negative 10.5 plus 7.5 gives us -3. So we're going to rewrite this. So we're going to have 168 minus 3c. So what do we do now? We have to get c by itself, right? So to get c by itself, I subtract 168. So -3c, 141 minus 168. I divide by -3. So c is equal to 9. Okay? So c is equal to 9. In other words, how many child tickets were purchased? 9.
So, look, this is what I don't understand. We did all that stuff just to get 9.
Now, if we have 9 child tickets, how many how many adult tickets do we have?
Huh?
So now we have to do another substitution. We know that A plus C equals 16. I'm gonna substitute. What am I substituting? I'm substituting C for 9. So I'm gonna go A plus 9 equals 16. So A equals 7. Huh? Yeah. Yeah. So next weekend, Marnie wants to attend either Carnival A or Carnival B. Carnival A charges $6 for admission, an additional $150 per ride. Carnival B charges $250 for admission and an additional $2 per ride. In function notation, write A of X to represent the total cost of attending Carnival A. Okay, so let's say we have Carnival A. We can write A of X. Or that's the same thing as Y. Okay. And then we have Carnival B. So Carnival B is represented by B of X, or also Y. So now we can say that Carnival A charges $6 for admission and $150 per ride. So let's say we can represent X as a number of rides. So we can say something like this. So it's going to be $150 per ride plus the $6 admission at the door. Carnival B, on the other hand, charges $2 per ride. That's 2x plus $250. And that's all Part A wants us to do. Part A just wants us to write the equation for Carnival A and Carnival B. Now, if you guys use Y instead of A of X, I'll give you full credit. So you can use Y, that is function notation. Okay, now it says determine the number of rides Marnie can go on such that the total cost of attending each carnival is the same. So you want to see when both of them are the same. Because the Y is by itself essentially, okay, we can take that and we can go to our calculator. Okay, so that's this calculator here. We go to y equals. Okay, so that's gonna be 150x, right? It's 150 per ride plus the $6 admission, and y2 is going to be $2 per ride. 2x plus 250 on entry. So we put that in the y equals, then we graph just to see more or less what's going on. Okay, so now we're gonna go to hit second graph, okay, and we want to see where y1 and y2 are equal. So y1 and y2 are equal at 6 and 50. In other words, when they go on 7 rides, whether they go to Carnival A or Carnival B, at 7 rides, they will both pay the same price. Okay, so you can actually just put those values in. Okay, you can just copy those values in from your table. Okay, you can just put those values in, and you can just highlight where the solution is. So the solution is at 7, 1650. That's an alternative to actually graphing. Okay, if you wanted to do the graphing method, that's fine too. Okay, so to graph, we see that we start at 6. 1, 2, 3, 4, 5, 6. Okay, and the other one starts at 250. Now the only thing is like halfway points. So this is we're gonna go 1.5 up, 1 to the right. So we're gonna go up 1.5. So we're gonna kind of be halfway. Okay, we're gonna go up 1.5 over 1. Or we can go down. We can go down 1.5 over 1. Down 1.5 over 1. Down 1.5 over 1. Okay, so actually in the graph actually won't show it, so we can just result to the y showed using the table. Okay, part C. Marie wants to go on 5 rides. Determine which carnival will have the lower total cost. Well, if you want to go on 5 rides, we go back to the calculator. Well, at 5 rides, y1 is going to be $13.50, while y2 is $12.50. Okay, so we go back. So at Carnival A, sorry, this is part C here. Part C here, you can actually put the the table of values again. Just copy whatever values there. So for part C, so at 5 rides, Carnival A is going to be $13.50. So Carnival A will cost $13.50. Carnival B will cost $12.50. Okay, and that comes straight from the table of values. All right, so I think we answered all parts A, B, and C. Equation algebraically using the elimination method. By looking at this, we see that we have the opposite. We have a positive and a negative. So we clearly see that this is going to cancel out. And then 3y plus 1y is 4y. 20 plus 4 is 24. You get y by itself, so we're going to divide by 4. Y equals 6. So then we're going to plug that in. We're going to do a substitution for 2x plus 3y equals 20. So we're going to substitute y for 6. So we're going to replace that one with 6. It's going to be 2x plus 3 times 6 equals 20. 2x plus 18 equals 20. Subtract 18, so 2x equals 2. So we divide by 2, we get x equals 1. So that's our solution right here. 1,6. Alright, so we have another solve the system of equation algebraically. Here we're actually going to see that we have a negative and a positive, and there's an invisible 1. So actually the y's are going to be canceling out. So 3x minus 2x is x. We're adding. 7 plus 2 is 9. So this is actually an easy one. X is 9. Okay, so now we're going to substitute into one of the equations. We see negative 2x plus y equals 2. So we're going to have negative 2 plus y equals 2. This is negative 18 plus y equals 2. We add 18. Y equals 20. So we have our solution, 9, 20. That's it. So the last problem says the homecoming dance at Liberty High School happened last Saturday. Many students bought tickets in advance for $5 each. So we have our first group of students, right? Who bought tickets in advance. And they bought it for $5 each. Other students bought tickets at the door. So those who bought tickets at the door was $7 each. And in all, 290 students attended the dance. That's another important information. Okay. And 1,790 was the total for all ticket sales. Okay, so we can underline that. It says create a system of equations to calculate how many students bought tickets in advance and how many bought tickets at the door. Write the system of equations and solve algebraically. Okay, so we are going to, let X represent the students who bought in advance. let Y represent the students who bought at the door. Okay, so now we can say that the number of students that attended the dance, and we don't know whether it be those who bought tickets in advance or at the door, we can say that the number of students that bought in advance plus the number of students who bought at the door is going to equal 290. And then we also know that the students that bought tickets in advance got it cheaper. So X is what represents the students in advance. So those students, so we can say that 5X plus 7Y, and the total amount of money that came in from all ticket sales right here is $17.90. Okay. Now I gotta get X by itself or Y by itself. Doesn't really matter. So let's say I get say we get Y by itself. So we subtract X. So Y equals 290 minus X. Okay. Now once we get Y by itself right here, we see our swap, right? Under our French fries. French fries and onion rings. Okay. Now we can either do that and do substitution, or we can do elimination. I find elimination to be easier. So we can take that and substitute it for Y. We can substitute it here. Now let's say you didn't like substitution because the problem says to do substitution or elimination. I find students like elimination more, so let's try elimination. So we have X plus Y equals 290. 5X plus 7Y equals 1790. In order for the X to cancel out, I can multiply the top by -5. So now I'm going to have -5X, -5Y is equal to 290. 290 times -5 gives me -1450. And then we have our bottom equation. So now we can add them up. You see that's going to cancel out. -5 plus 7 is going to be 2Y. And we're going to have 1790 plus -1450. It's 340. You divide by 2, you get Y is equal to 170. Okay, so now we can plug that in to either one. So let's say we plug it into X plus Y equals 290. Either way, we're going to do some type of substitution. We're substituting Y for 170. So I'm going to do my swap. I don't like Y. Okay, so I'm going to say X plus 170 equals 290. I subtract 170. X equals 120. So I can say there were, so how many students bought tickets in advance? Notice that X represents those who bought in advance. So 120 students, you can see 120 students bought tickets in advance. And Y represents tickets at the door. Ticket at the door 170 to 170 students bought at the door. So that's our solution. Or we can say 120, 170. Alright, that's it. Okay, all the best. Practice, go over these questions, and all the best for tomorrow on the test. Alright, have a good one, guys.